GLSL, also known as shader code, can give you access to anything that you desire inside of AI in terms of generative graphics or image modification. So what we're going to do, we're going to have a quick look here at how we can implement some shader code inside of a Salvation patch, and we'll actually add some code ourselves and create a 3-channel mixer. Okay, so first of all, let's add our rectangle. That's the starting point for our patch. And we'll add a window to this patch as well. So both of these, window is in GL section, and the rectangle is in the generator section. Now we also need a module to put our GLSL code inside of. So in the GL section, there is a module called GLSL program. So I'm going to select that and place him. Then I'm going to right click, load alternate skin, and I'm going to choose compiler output. I quite like using this version of the module because it will give us some feedback here and tell us if there's an error on a particular line or anything like that. We also need another module here called the bind texture module. So what we're going to do, we're going to bring our textures in, and then we're going to have individual control over the brightness of each of those textures. So I mentioned that we're actually going to do a 3-channel mixer. So I'm going to add my 3rd channel there. I'm just going to rename it so it's got the same naming convention as well. There we go. So now we can start to connect our modules together. Rectangle into GLSL program, GLSL program into bind texture, and bind texture into our window at the end. Okay. So we're also going to need a way to input our text, our code, into this module, and we're going to use a notepad for that. So insert module, text, and notepad. And then what I'm going to do, I'm just going to stretch this out a little bit so that I can see my code a little bit better when it's in there. So I'm just using the control button to move that port, holding control and dragging with my left there, and holding control and dragging with the left. Okay, that's great. And we're going to connect this one to the fragment code port. Okay. Let's just open that up a little bit. Okay, so we've got the basics for our patch there. And what will happen is during the code, we're actually going to tell this program module that we want some ports to appear on there. Then we can connect a dedicated fader into each port, and we can individually control the intensity of each of our 3 layers then. Okay, so I've actually prepared some code here. And what I will do, let me just copy it in there, but I'll actually explain what we've got going on here as well. So I'm just going to copy, click in there and use Control V to paste, like so. Okay. So just to explain a little bit about what's going on here. Now obviously OpenGL programming language and GLSL shader code, which is a subset of OpenGL, they're very complex things, and like any coding language, it's essentially maths and algebra that you're performing, especially in the sense of graphics, because we're manipulating numerical values for pixels. So it can be worth putting in a bit of maths practice before you jump in headlong. Now just to kind of give you an idea of what this code here itself is doing, so the first bit, this uniform vector for layer 1, we're creating a vector and we're calling that vector layer 1, and we're saying that that vector has 4 places. So if you think in relation to a colour, we have red, green, blue, and then we have our alpha. So that's our 4 places, our 4 vectors. And because we're going to be doing 3 layers, we're going to set up a 4-place vector for each of the layers. Then we're going to have 3 inputs on the module. These are going to be what our faders are going to attach to. And we're calling those input 1, or input 2, and input 3. Then we need to reserve an area of memory to actually draw the image, and that's what's happening here. This is us giving each of those separate areas its own name. So this is texture 1, texture 0, text 1, and text 2. So where we have the statement void main, this is where the processing actually starts. So before then we're just setting up variables and user parameters. So this is saying, this first line, it's saying that the 4-place vector called layer 1, this is equal to the 2-dimensional texture, and that 2-dimensional texture is the image taken from text port 0 on the blind texture module, combined with the open GL texture coordinates for that area. And so we've got the same for our second and our third layers. And then finally we have the operation itself. So we've set up the components, we've told the layers what they're comprised of, and so now we're going to specify an operation, and we're calling this operation mixed. And so here we're saying that the operation mixed is equal to the pixel value of layer 1 multiplied by the value received at input 1. And we're doing that in a bracket, so we're multiplying those together. Then we're doing the same inside the next set of brackets and in the third set of brackets. And then once we've calculated the contents of the brackets, we're then adding those three together. So that's our actual operation. And right down here at the bottom is the function, which is saying that the fragment color, that's to say our components in our image, are equal to the operation mixed. So as we saw, mixed is layer 1 times input 1 plus layer 2 times input 2 plus layer 3 times input 3. Okay, so let's get that out of the way. Now that we've got that in situ here, so what we'll do first of all, let's bring in some textures here, because we're going to have 3 texture inputs. So I'm just going to open my browser. I'm going to bring 3 images in. 2, and let's have another one. Maybe if I go all the way down here, I'm going to use this coloured square, which I've got handy there as well. Okay, so just to confirm, we've got test pattern, we've got orange and blue circle, and we have our square grid. It's a UV grid from Blender, actually. It's a really handy tool if you're using Blender. So if I connect these up, we will see the combination of those images, and all the module is doing is just adding those images together. Let's just crop that. There we go. Now we actually want individual control of each of those layers, so that's why we put the uniform float input 1, input 2, input 3 in our code. So hopefully when I press compile here, it's going to look at this code for us. It's going to see if there's any problems with it at all. If there are any problems, it will tell us the line where there's a problem. It may even tell us which character it has a problem with. Otherwise, if there's no problem, it should say compile OK, and we should see 3 ports arrive here, labelled input 1, input 2, and input 3. So we press compile, and it's good. So we can see those ports there now. And now because there is a 0 value being received at the ports, the brightness of each of our textures has been reduced to 0. So I'm just going to add in some controllers just to complete our patch. I'm going to duplicate that up a little bit. In fact, let's use faders because a fader makes sense. So let's go for a horizontal slider. Copy, paste, paste. Connect that to the first input. Second one to our second input. And to input 3, and hopefully now we should see our test pattern, our orange and blue, and our UV grid, and we can vary the amount that we see of each layer. So although this is a fundamentally fairly simple piece of shader code, hopefully it gives you a very small insight into how it works, how you need to structure your patch to work with shader code, and some of the possibilities. One of the really key things to remember with shader code is that with graphics, everything is numerical. So you can modify every aspect of your image given basic algebra or formula that you enter into the shader code module.